One of the things we're often asked to do is to evaluate an expression at certain values. So here are four expressions, and an expression is this algebraic object. You can there's usually not an equal sign involved with an expression, so that's one way you know that it's this expression. But each of these expressions has one or two variables. Let's take a look at this one right here, for instance. It has x's and y's. And remember, the thing about x's and y's and the thing about variables is that they act as holding units. In other words, we can replace the x and the y with values and actually do the math. So as I look at this expression, it's 2 times this thing that is in the x box minus this thing that is in the y box. So when we're asked to evaluate an expression, basically we're being asked to substitute numbers into the appropriate variables. And so as we go along here, starting with this first one, it would look like this: 5, and then the variable is x is 3. Now you can save yourself a little bit of heartache by not just plugging a 3 in for the x, but put parentheses around the 3 and replace the x with parentheses, with 3 in a parentheses. That will help you keep track of the signs and things like that. And then it becomes an arithmetic or an order of operations problem, and we see, oh, we've got a multiplication right there and an exponential term. So let's do the exponential term first. 5 times 3 squared is 9, and 5 times 9 is 45. And so we get 45 as our answer. Now in the second problem, we're going to substitute values in for x and for y. So it's going to look like this: 2 times x minus y. And then we do our order of operations. Remember, when you have that kind of thing, a number right next to a number in parentheses, that's multiplication. So we're going to do that first. 2 times 3 is 6 minus. Now I can also drop those parentheses with the understanding that this is now, I can think of it as a negative 2. 6 minus 2, or 6 plus a negative 2. But those parentheses are not needed there in this case. 6 minus 2 is a 4. In the third example, now sometimes you don't need the parentheses if there's just a variable by itself. Like in this case, all of these variables are by themselves. So I can just do the 3 for the x, the 2 for the y, the 2 for the y, and the 2 right there. And I don't need the parentheses. And then now it's a fraction problem, and I say, oh well, I'm adding 2 fractions, got to have common denominators. Luckily they have common denominators, so my answer is going to be over a 2. 3 plus 2 is 5, and then I look at that and I say, oh, that is already reduced, so that's my final answer. And then the last example, we can do it like this: 3 in parentheses minus 2 in parentheses. Or once you get comfortable, you can write it like this: 3 squared minus 2 squared. The parentheses are really there and really helpful when one of the numbers that you're evaluating the expression at or plugging into an expression is a negative number. With a positive number, it's not so critical. But here, order of operations tell us to do the exponents first, so this would be a 9 minus a 4 or a 5 as a final answer.